Hey, what's up, guys? This is Cheng here. So this time, LeetCode number 1982, find array given subset sums. So this one is a very interesting yet very hard problem. And so the description says you're given an integer n representing the length of an unknown array that you are trying to recover, right? And then you're also given like an array sums containing the values of all the 2 to the power of n subset sums of the unknown array in no particular order. Okay, and then you need to recover that array, the unknown array. You just need to return any of them. Okay, right? And note that so it's guaranteed that there always be at least one correct answer. Right. So for a few things, so what is a subset? I think most of you should already know the subset, and why is 2 to the power of n. So this should be pretty straightforward, right? Let's say we have two numbers here, right? Let's say it's 1 and 3, right? So what is the total subset for this one, right? So the first one is always 0, right? The first one is always like empty, which means we don't pick anything, right? So the second one is picking 1, and then 3, and then it's what? 1 and 3, right? So that's a subset, okay? And subset means that the order doesn't matter, right? And 2 to the power of n, that's the total number of the subset, because if we have another 5 here, right, we'll have like 8 in total, right? So that's how we get this one. And the sums here, basically it's giving us the total, okay? The total for all the subsets. And for example, right, so let's say we have n is equal to 3, right? And obviously the length of sums, how many sums we'll have? We have 2 to the 3 of 2 to the power of 3, which is 8. That's why we have 8 total sums here, okay? And as it listed here, right, because we have different subsets, and the output is this. So basically, we have 3 numbers, 1, 2, and minus 3, and this one can give us this subsets, okay? And then here's another one, and that's that. So the constraint is like n is like it's only a 15, right, length. Okay, so to solve this problem, we need to make a few observations. Plus, we need to have some like knowledge on some basic subsets concept, right? So the difficulty for this problem is that it allows you to use a negative value. I mean, if this one were only allowing you to a positive value, that would be a lot easier. But I think even that I mean it's not that easy. But comparing with this negative value, right? It's easier. But to solve this problem, we need to use that easier version as a base. So let's say we only allow positive value or non-negative values for this problem, and how can we solve it, right? Let's try to use an example here, okay? Let's say we only have three numbers, right? We have 1, 3, and 5. Okay, so that's the three numbers we have here. And so how about the sums, right? For all the subsets. So obviously we always have 0. 0 means that we're not picking any numbers, right? And then we have one number, which is 1, 3, and 5, right? And then two numbers, 1, 3 is 4, and then 1, 5 is 6, right? And then 3, 5 is 8, and then in the end we have 9 here. Okay, so we have this number, this sums list, and how can we recover this this one, the original array here? So to solve this one, assuming everything, all the numbers are positive, we need to make, so one of the observations is that the second smallest number in this one is 1. So what does this one tell us? Basically, this 1 has to be one of the numbers. Basically, it has to be the smallest number of the current in this array here that we're trying to recover, right? And why is that? Because since all the numbers are positive, right? And because any time when we pick two numbers, the sum will become bigger, right? So which means the smallest, the second smallest number besides 0 will be the smallest, basically will be one of the numbers in this array for sure, right? Which in this case is 1. Okay, so and let's say, okay, we already find one number which is 1, right? And now we have two numbers left, which is x and x. Okay, and how can we find these two numbers? So in order to do that, right, we have this kind of 8 sums in total. What we need to do is that we need to divide this sums into two halves, which means we need to divide it into this two halves. And why we need to do this? Because obviously, with two numbers, the total sums will the total subsets will be 4 in this case, right? And if we can find, right, if from this 8 sums, if we can find the 4 sums for these two numbers, then we can utilize the same logic to find another number, right? Similarly as how we find this 1 from this 8 subsets. If we have 4 subsets for these two numbers, then if we sort it, right, and then the second smallest number will also be the number, one of the numbers in this two number, which is going to be the smallest number as well, right? Okay, so and now our question is that how can we split these two? Basically, how can we find those 4 subsets or 4 sums for these two numbers? Okay, because we already have 1 here, right? And we know that every time when we add one number to an existing subset, we're doubling the total sum, right? That's why we from 4 we have 8, and if we have another numbers from 8 we'll have 16, right? And after splitting if we're trying to split this one into half, so what do we have? If we try to remove this one from this subset, what we will have? So let's say we have this part A, this one and this one. If we do a +1, okay, so this uppercase +1 will equal to the lower to this lower group. Okay, and if we so which means that because because by including 1 here, right? For example, let's by including 1 here with existing subsets, right? Basically, we're adding 1 to each of the existing subsets for these two numbers. That's why if we divide this sums into two groups, the upper group +1 will equal to the lower group. Okay, and this upper group will be the group will be the sums for the other two numbers, right? Because, for example, let's say we have 9 here, right? So in this case, let's assume we sort this number, we sort this race from the biggest to the smallest, right? So the biggest is 9. So the 9 obviously will belong to the lower group, right? Because the 9 is the biggest, right? It is the greatest number, and this one has to come from some number plus 1, right? That's why the nine is here, and then we will have like 8, right? So now we have 8 here, and then what's next? And then because 8 and 9 are gone, right? These two are gone, and then the next biggest number is 6, right? So now we have 6, and then we'll have 5, right? Same thing. Now 6 and 5s are gone, so the current biggest is 4, right? And then we have to put 4 below here because it cannot be here, because if we put it 4 here, 4 plus 1 will be 5, but we don't have 5 in the sums anymore, right? So that's why we're gonna put 4 here, and then 3 here, and 1 here, and 0 here, right? So now we have split this sums into 2 groups, and the upper group will be the group that for the other 2 numbers, the numbers that we haven't recovered, right? So now we have 0, 3, 5, 8, and as you guys can see, we can just apply the same logic to this group, right? So now we have 3 as the second smallest number, and which means 3 will be one of the numbers in this group here, right? So from here we get 3. We'll have 3 as a number, okay? And then with 3 here, we can just split this one into 2 parts again, right? By applying the same logic, will be this one, this one, this one, this one, right? So now we have 8 here. Now this one, instead of plus 1, we need to plus 3, right? So it's going to be 5, and then here it's going to be 3 and 0, right? So we have 3 here, and now here it's 0 and 5, right? So this one, obviously, whenever we only have 2 numbers left, right? So we have 5, right? That's why we have 1, 3, and 5, right? So that's how we solve an easier version for this problem, which only allow us to use a positive number. Okay, yeah, because this one is going to be like there. Basically, this one doesn't have any branch, right? It only has one path, because it guaranteed us there will always be a, a solution, a result, right? That's why we can always split this one into 2 halves, and then basically recover all the rates here, all the numbers here. So if you understand this part, right, and we're gonna use the similar logic to solve this problem, which allows us to find allow us to use the negative value. Okay, so if you take a look this one a little bit closer, you'll figure out, so what's the most important idea in this problem. So first is that we do a divide and conquer, right? So we divide this into 2 parts, and the prerequisite of us dividing this sums into 2 parts is that we already figure out one number already, right? That's how we can divide this one into 2 parts, because we already know that one of the answer, right? One of the number. So if we can find one of the numbers, and then we can divide the sums into 2 parts. But the question is that with the negative values, how can we find this number? Okay. So let's say we have some negative values. We have negative, 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 and then we have a positive, 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 something like this. Okay. So assuming we also sort the sums from smallest to the biggest. Okay, so we have a max, right? So what does the max equal here? The max is equal to what? Obviously, let's say we have some negative values and positive values. So the max will be all the values, all the sums for the positive numbers, right? Okay, so that's that, right? All positive numbers, all positives. How about the second max? So what is this? How about the second max? So what does this one do? So the second max could be, so for this one, we have two options here. We have two scenarios. So the first scenario is that, the second max will be this one, will be this part, uh, except for the smallest, positive number, right? So that could be the uh, one of the second max value sum, right? Or it could be all the positive values uh, plus the biggest smallest number, right? So this is going to be the uh, second option here, right? So basically, since we have these two options, right, it could be either including this one or it could be either like representing this one or including this one or including this one, right? Either the first positive number or the last negative value. And if we do a subtract between these two, right? And what we'll get either this one or this one, right? Obviously, this one could be this is a positive number, and for the negative one, we have to reverse the sign here, right? So now we almost have like a fixed number, right? But in our case, remember, so for the all positive number case, there's no branch. We simply just follow this one divide and conquer algorithm, and it will definitely give us the right answer. But in this case, right, we'll have like two branch here. It could be either this positive number, or it could be this negative number. So which means we have to try both, right? So for positive numbers here, right, we can simply use the same logic, right? Basically, we're trying to pick from the biggest number, right? We sort this array, we pick the biggest number, and then we try to find if there's a matching number. You can find like if we can divide the sums by using this positive number, right? But how about this negative value, right? If we're trying uh, to use these negative values, how can we divide? How can we divide this one? It's almost the same. The only difference is that we have to start from the smallest, right? Because and why is that? Because uh, by including these negative values uh, from the original subset sums, right? All the subset sums will become smaller since this one is a negative value. Um, that's why, when we try to split these sums into two parts, we have to try from the smallest value first. Okay, let's say if we have a smallest value here, right? Basically, we have a smallest value here. This one, like this is the sums, right? All the sums here. We have to try instead of from the beginning. We have to try it. Sorry, instead of trying it from the end, we have to try it from the beginning. is going to be the smallest value, right? Because from this one, because from this similar as this 9 here, right? Let's say this one is -10, right? And our number is like, let's say it's negative, this one is -2. Okay, so with -10, right? If we do a -10 plus 2, we get a -8, right? So which means that this we have a -10 here. It's going to be like this one, right? These two parts. So which means that, below here we have -10, and here we have -8. Okay, so which means that, the -8. So this one will be the subset for this remaining numbers here. Okay, because since like I said, by including this new this negative values, all the sums will become smaller, right? That's why, similar as how we get the biggest value for the positive case, we need to start from the negative case. Because like sorry, I think sorry, I sorry about repeating myself, because I just want to make sure you guys understand this part. Because like I said, so the reason being is that, again, so for -10, since it's the smallest value, right? And we are sure that, the 10 has to belong to the lower case, right? Because if the 10 -10 belongs to the uppercase, then this -10 -10 then also do a -2 will become it's going to be a -12, but it doesn't exist. That's why the -10 has to be in the lower part, right? And then then we have -8, and then we keep finding the smallest of the kernel, just like how we did for the positive one, right? And yeah, I think that's pretty much the basic idea. So we have this part for the positive case scenario, and for the negative case, we use the maximum sum, subtract the second max sum, and then we have a value, right? And then we have to try both the positive value and the negative value, because it could be either of these two scenarios, right? And then with these two numbers, we'll try to split them up, okay? And then we'll basically try to find a correct, find like a path that can lead us to the end, which means we'll only have two numbers, right? And one of them has to be 0, right? Yeah, I think that's a long explanation. Let's start coding then, and maybe I will explain a bit more. So so like I said, we need a DFS, right? So we have a sums here, and then here we just return the DFS of the sums, right? So before that, let's sort the sums, okay? Because we want to process them either from the start or from the end, right? Okay, so the base case, okay? So the base case is this. So we have the n is equal to the length of the sums. And then basically if the n is equal to 2, right? So which means we only have one letter, we only have two left, right? Let's see. We will return the non-zero ones, right? The non-zero one, which is the how can we return it? We can do this. We can do a sums remove. This is like such a lousy way of doing this, but okay, I think there should be another way of doing it. Sums dot 0. Okay. Yeah, I think so. So basically, I simply remove 0 from the sums, and then I just return the other one. Okay, as a number. Okay, and then we have x, right? So we have x going to be the sums of -1 minus sums of -2. Basically, this is the maximum. Subtract the second maximum, assuming the sums has already uh, sorted, right? So now we need to try two scenarios, right? So first one is we try positive x. Okay. So to try the positive x, we have, let's say I'm going to have a new sums 1, right? Okay, so there's a trick here, because like I said, so when splitting this number, the sums into two parts, right? So assuming the sums has already sorted, we don't want to remove it, right? We don't want to remove from the list. Like even though I said, we after picking this 9 and 8, we want to remove this 9 and 8 from this array, so that it will not affect the others. But removing is kind of expensive, right? So if we're doing that, this will TLE. So what we can do is here, instead of removing it, we can simply mark that number is not usable, right? How can we do it? We can simply do a counter, right? So we can count the appearances for each of the number, right? And then every time we find a match, we simply just decrease the count by 1, right? So we have a counters of this. And then for and since we have the counter here, right? And since we have like, so we try this number here, right? And this number minus x could be the corresponding part could be like this one, right? And so that's why we want to process from here to here, right? And we process them one by one, and then that's why I'm going to do this. So I'm going to I'm going to reverse this sums, right? So we have a b going to be a minus x, right? So which means, so this a is the lower part, right? And the b is the upper part. Okay. So, and then we check this one. So if the count 1 of a is positive, has a value, and the count 2 of b is positive, okay, and then we know, okay, we find a like a match, right? A pair. That's why we can just new sums 1 dot append to b, right? And then we do a count 1. We have to decrease the count, right? And then we do a count 1 of b, right? We decrease this 2, and then we move to here, right? Because since we're trying the numbers from the biggest to the smallest, and then we're sure that each number, each a here will be the biggest number in the current sums array, because we removed the previous biggest number from this array by decreasing the frequency. Okay. And then here in the end, we check. Oh, by the way, so here, I was trying to do something like this. If it doesn't work, couldn't find it. I was trying to break it, but this is wrong, because it could be the account 1A is empty, right? and then we'll still try to do it, right? We'll still try to we still need to move the cursor forward to keep trying the others. Okay. I think there might be another way. Basically, if this one is not empty, but this one is empty, right? So if that's the case, then we know. I think then we can break it. Yeah. I think something like this. I think we can do this. Okay. So if right count b is not empty, then we do this, right? Else, right? Else, I think we can break here, so that can uh, improve the performance a little bit. So let's see. Okay, now we have this answer one. This one gonna be this. So basically, we check if the length of this new sums one is equal to the n divided by 2, right? So we check this. Basically, we're trying to see if we can successfully split these sums into two parts, right? So if the length is equal to the half of it, then we know, okay, we have split this one, right? Successfully. That's when we can do the recursion, which is gonna be the x, right, plus the DFS of the new sums one. But here we have to reverse it. Okay. So here, what I'm trying to do is that I'm trying to find a way to find us the correct answer, right? So first we know, okay, so if we have successfully split it, then we know, so the number, the x will be one of the number. So the remaining will be what? So the remaining will be, we need to pass in the remaining sums to it, right? So here but we don't have to sort it anymore because we are processing from the biggest to the smallest, right? And then since we're doing a append here, so after doing this, so this new sums will be already sorted from the biggest to the smallest, right? That's why I reverted. I reverted back to its original sorting, which is the smallest to the biggest, so that we don't have to sort for each of the DFS. Okay, so that's answer one, right? But remember, this answer one could not be the answer, right? Because we also have answer two here. The answer two is we try the negative value, right? I mean, I think we can. I'll just try to copy and paste negative. So we have a sum 2, count 2, right? And then here we're gonna answer 2, sum 2, sum 2 here. So for this one, we want to, like I said, we want to process from the smallest to the biggest. That's why we don't have to reverse it, right? But this one, like, we have to do a plus x, right? Remember, so we have this one, right? We have this we have minus 10, right? So then the x is minus sorry, the x, so the x will be a minus 2 in this case, right? And then for this one, we're trying to find the minus 8. That's why we do a plus x. Okay. And so we have count 2, sorry, this one. Yeah. And here we don't need to reverse it, right? Because we are processing from smallest to the biggest. And it will still be sorted. So it's going to be answer 2, right? So now we have these two answers. One of them is the answer and the other one is not, right? Because we always know there will be an answer. And how do we know which one is our answer? right? So obviously, the one who has more fields, who has more numbers will be our answer, right? I mean, so we can do something like this. So we answer, you return answer one if the length of the answer one is either greater than the length of the answer two, right? Else answer two. Okay. Yep. I think that's it, right? I mean, this should work, but I guess this will TLE. Oops. Parameters to generate types must be. Did I? Oh yeah, counter. It's a function. Oh, I see. So here we have there's some like edge case, no, some scenarios we haven't taken into account, which means um, you know, this sums has to include zero all the time. Basically, it failed here because it's trying to remove zero, but it doesn't exist. Why is that? Remember. So no matter how we split these two parts, right? So the remaining parts, we have this 1, 3, 5, right? So this one is we find it, and then we're trying to get the subset for the remaining two numbers, right? Which means that there always be like zero, because zero means we don't pick anything, right? So which means that as long as the zero does not exist in the sums, which then means it's not a valid path, right? I think we can simply do a check here. So if zero not in sums, right? And then we return the empty. We return empty because we're using the length. We're using the length to verify if this path is a correct one, right? And if this path is not, and then we simply return empty, which will result to a shorter answer here, right? And yeah, so let's try it again. Okay, so this one accepted. So let's try to run it. Did I? Oh, I think I know what happened. Here. So when we try the negative case, instead of x, we need the minus x, right? Yeah. So it works, right? Um, not fast, but it passed. That's all it matters, I guess. So yeah, that's basically the implementation here. So this part actually, this one is crucial because this one can help us remove a lot of invalid scenarios, right? And otherwise, if we only check it here, let's say if we check it here, right? So let's say if we check it somewhere here instead of at the very beginning. Okay, if that's the case, if we run it again, I believe it will TLE. This is because let's say the current sums, yeah, see it's TLE. Let's see if the current one doesn't have a zero. Let's say it's a 3, 6, 10, 12, something like this. This one definitely it will not be a valid path because like I said, zero should always be there because zero means we don't pick anything, right? So in this case, there's no need to keep splitting it into half, right? Into two parts, and that's why so that we can basically terminate early, right? That's why we remove this one, move this one all the way to the top. to do some pruning here. Okay. Yeah, and so for the time complexity, so as you guys can see, we have how many DFS here, right? So we have what? Every time we split this one into half. Okay. So let's say, for example, we have n here, right? So which means for each of the time, then we are processing n minus one length. Sorry, not n minus one length, n minus one numbers. Okay. Every time we are removing one numbers from the sums here. And in total we have n numbers. That's why, and every time we are splitting this one into two parts, which means it's going to be a 2 times 2 times 2 to 2 times 2 to the power of n, right? So that's the branch, the total time of the branch. And for each of the branch, we do a for loop, right? So we do a counter, we do a for loop, we do a counter, we do a for loop, and it's going to be a times n in this case, right? So that's going to be the total time complexity for this one. Yeah, I think that's it for this problem. I mean, just to recap, right? I know this one is a very hard one and it's a long video. And so first we're trying to solve this problem by assuming there's only positive numbers, and then that's when we figure out, okay, we can just fix one number, right? And then we try to remove the number from the numbers by splitting these sums into two parts, right? And then we do it in a recursively so that we can get the numbers one by one, right? But when it comes to this problem, since we have negative values here, this one, that's why we'll use the biggest number minus the second biggest number to get x, right? But for this one, in this case, we have two scenarios. The x could be either this number or it could be this number, right? And we have to try both. And for the positive case, it's the same as the easier version, right? So we start from the biggest number, right? And then we try to split them into two parts. And for the negative case, we need to start from the smallest number, and then we split into two parts as well. And when we do the splitting, we use the counter, right, to improve our performance. Instead of removing the numbers, removing the number from the arrays, right? And then in the end, since we have two scenarios, we'll pick whichever can lead us to the final answer, and which is the one that has the longer length, right, the bigger length, because it's guaranteed we always have an answer, right? And yeah, and one more thing. So here's a little trick here. We only sort once at the very beginning, and then later on, since we're always either process from the biggest to smallest or process from the smallest to the biggest, we simply just need to reverse it if we want to keep the original sorting, right? Cool. I think that's everything I want to talk about for this one. And thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.